Hello, hello. Hope you're doing okay today. We're going to do something a little different than I've done before in stream, and that is, I figured I saw Ben Dixon, I think it is. I'm trying to remember who it was. Do this where he went through a book, and I thought that would be kind of fun to do. And so I'm going to just start with this. It's something I wanted to do anyhow, so I figured I'm going to jump in, and as much as people want to follow along, we can kind of do it together. So the book is Eloquent JavaScript. It just was revised in 2024. So I figured this is as good time as any to like go through a book together. So that's kind of what we're going to plan to do. And obviously at the beginning here, it should be fairly basic. And as we get going, hopefully we'll get to pick up some extra stuff. There'll be some projects and things like that that we can work on. I don't think I'm going to like read it directly. I think as we get a little bit more advanced, I will probably do a little more reading ahead of time. And then we'll go through it together. But yeah, if you can let me know if you can hear okay, if volume's okay, all that kind of stuff, that would be great. All right, well, let's, before we get going too far, I do want to jump over to my other screen here, and I want to chat about something real quick that's important to me. Let's see if I can get it all set up. Okay, cool. Hey everyone, welcome. So I wanted to start by talking about this childhood fundraiser I'm doing. I do it every year. You guys have always been so generous, and we've just hit a little over $1,200. Now we still have a lot to go, and I was pretty aggressive this year because I'm like, I think we can do this. We've already had several people give. The nice thing is I have like 37 or 38 incentives for you to give, and I've only got like maybe 7 people who've sent me actual receipts, and that's the way you enter into the drawing. But I've got stuff from Vercel and Mux and Cloud Cannon and Git Tower and a bunch of really cool extensions and Quokka.js and Wallaby.js. I've got Warp Pro for a year, a theme for your terminal and editor and all that kind of stuff. Neon, a database solution. I think I mentioned just about everything there. My own Astro course. And so I've got a ton of these things to give away. And right now, basically, I don't have enough people to give them to. So if you give at least $5 and you send in your ticket to me or your receipt to me via email, so right down here, all you have to do is enter before the end of the month, send in your receipt to me, and then I'll enter you to win one of these things. And right now, you're guaranteed to win something because I don't have enough people to give these things away to. I'd love to see us hit like $2,000 by the end of the week. I don't know if that's at all possible. That would take a lot of generosity on people's parts. But the cool thing about St. Jude is they're a Children's Cancer Research Institute. So not only do they care for kids locally, but they spread their research globally, and they're really like the global leaders in children's cancer research and other life-threatening diseases. Their goal is to bring down that childhood rate of if you get it, you don't make it to nothing. They've actually done a ton within the U.S., and now they're in a huge push worldwide, not only to spread their research, but actually to spread resources as well. If you're a patient of St. Jude, you never pay a dime. Your family gets flown there for free. You get taken care of for free. Your kid continues to go to school. They have like a whole school within the hospital where they try to keep you up to date. They just do a ton for both the families and then also the world when it comes to children's cancer research. They opened in like 1960, and they've massively improved the childhood cancer rate, not only in the U.S., but again, around the globe. Right now, there's still 90% of kids worldwide without access to adequate treatment. So a lot of what they're doing right now is doing a huge push globally to try to help kids with cancer. So I'd love to see you give and participate, and then you get some really cool stuff. I mean, some of these things are years of free software, essentially. Others of these are like a pro tier of a software for an entire year. So I'd love to see you give towards that and show your generosity once again this year. Okay, well, with that said, let's jump into Eloquent JavaScript. You can find the link in the description for Eloquent JavaScript, and also the link for the fundraiser if you want to help cure childhood cancer this month. But right here, we're going to start with just the first one. The introduction is mostly like around how they're writing the book and that kind of stuff. Hey there, everyone. Gabrielle, Lucas, welcome. So we're just going to go through the very first chapter. And again, I'm not going to go through like every single bit of data. I want to mostly focus on JavaScript. And not like this stuff isn't important, but I'm going to stay away from more of just the CS stuff. So for instance, they're talking about like bits and how that translates between like binary and whatever the actual values are. Now, Not that memory is not important for JavaScript, but because it's a garbage collected language, like a lot of that work is done for you. There still can be ways in which you can do dumb stuff in JavaScript, but it does a lot for you. So it mentions here that a modern computer has more than 100 billion bits in its storage. This is its working memory. And then it also has like a hard disk or some kind of like non-volatile, the idea here of memory as well. So we'll work through a little bit of this, but basically you want to be able to work and know where your data is being referenced. So without getting lost, you want to separate these into chunks that represent pieces of information. In JavaScript, you call those values. So they're made up of bits. They play different roles. And that's a lot of what this whole chapter is about, or what are the different values you can store and reference and use within a program. So to get a value, you have to merely invoke its name, which is really nice. You can just say like, hey, I'm going to name this thing whatever. And then to get it back from memory, you just grab that name as well. So let's start with the first value. This is one of the primitives in JavaScript called numbers. So number types are just numbers. And in JavaScript, there's not a lot of complexity here because it's basically any number. There are, believe it or not, a lot more complexities depending on what you're looking at. So some languages allow you to say like this number can only be this large, or this number can like have a decimal or can't. Hey, Terry, welcome. Somehow when I said, hey, Terry, it invoked Siri too. So yeah, thanks so much. All right. So you can see here that you just write them like a number right here. And again, we're going to just kind of go through this, assuming that none of us know anything. Some of you may be coming very fresh to this. Others of you may be very experienced in this, and I'm always welcome to feedback too. If you're like, oh, you didn't explain that well, hopefully at the beginning here, we can do okay. So JavaScript uses fixed numbers of bits, 64 of them, to store a single number. I mentioned like things like Rust. You can actually say like, actually, I want it to just be this length of a number. So there are only so many patterns you can make with 64 bits, which limits the numbers. Now, it is true that JavaScript is intelligent in the way it stores those numbers, so it doesn't always store like that large of a section. It's just that you can store to that length with a number value. So the end decimal represents the digits you can represent. So like I said here, we only have 64 bits basically. So similarly, given 64 binary digits, you can represent 2 to the 64th different numbers, which is about 18 quintillion, and 18 with 18 zeros after it. So you can still store enough. It's just that you don't have like quite the control of the language to scope the size of that memory. But JavaScript kind of intelligently tries to do that for you. Computer memory used to be much smaller. People used to 10 groups into 8 or 16 bits to represent the numbers. Now we're up to 64, our phones, everything else as well. So if you accidentally overflow small numbers that can only hold 8 or 16 bits, you end up with a number that doesn't fit into a number of bits. Today, because computers, even the ones in your pocket, like your phones, like I mentioned, have 64-bit chunks, you don't have to really worry about that as much, especially if you're learning. All right. You can also do fractional numbers. You can represent them as well. And again, it's just the same value in JavaScript. This is something I'd love to see JavaScript get more control over, but I don't know how you could do that backwards compatibility-wise for very, very big or small numbers as well. So you can use scientific notation. One of the cool things here is like, which maybe they'll talk about this in a second, but if I jump down to the console, let me zoom in here. One of the things I really like to do with larger numbers, so like we'll call it this just num, is instead of using commas, is to use underscores, just because it's a lot easier to read. So that is one thing to mention. So like if I console.log, my num, there we go. So you can see that like it strips those out, but it is really helpful like storage wise if you happen to be storing numbers. Now usually you don't want just like magic numbers, but there are times where you have like a true constant that everything is being compared to or multiplied to or subtracted from, like some epoch or something like that. So whenever you have a large number, I like to do that kind of underscore. Okay, back over here. Arithmetic, you can do math as well in JavaScript. Math is famously fun in JavaScript and in a lot of programming languages, especially once you get down to decimal math. But a plus sign, oh, like you can run stuff in here. I didn't know that. Oh, look at that. That's good to know. So plus, multiplication, Those are operators. Let's see. Are they going to talk about, precedence? Okay, so we'll get down here. So like with normal math, as in mathematics, JavaScript allows you to kind of define what happens first, because by default, you kind of go in a certain order. So if you want this to be added first and then multiplied, you have to actually wrap this in parentheses. That operation happens first, and then the multiplication happens. For subtraction, you use the minus operator, division with the slash, multiplication we already talked about, and obviously addition as well. When operators appear together without parentheses, the order in which they're applied is determined by the precedence of the operators. If you don't know that, that's more of a math thing, so we won't pay attention to that either. But yeah, basically, usually on a very simple level, like multiplication and division happens first. There's also this percentage sign, which is the remainder operator. This is really nice when you're especially trying to figure out if something is like even or odd. You don't have to install a library for that. You can just do like X percentage Y, and the remainder is whatever happens after you're done with that division. So in other words, like 314, this modular operator is what it's called. I don't know if they say that here. I think that's what it's called. Modulo. Yeah, there we go. 100 then produces only 14 left, right? Because you'd have 3 hundreds that fit into the 300, and then you have 14 left. So this would equal 14. So it gives you whatever's left over. So for instance, if you want to compare and figure out if something is even or odd, you could say like console.log, just to see it here. We could say 314, right? 100. And then we could basically say like, if this is equal to, or like if this is divisible by 2. So yeah, so let's wrap all this like this. If I can type. So if this itself is divisible by 2, and if this equals 0, then I know that it's even, right? So if this equals 0, then I'll say like even. Otherwise, it should be odd. And if I did that correctly, I think I did, it should say even. Yeah. So when we're done with this, I know I have 14 left. When the 14's left, I say, if I, divide this by 2, will it be equal to 0? If so, I know it's even. Otherwise, it's odd. So that's one way in which you use the modulo operator. Okay, there are some special numbers in JavaScript. The first two are infinity and negative infinity. You don't usually need these a ton, and they're not super trustworthy. But anyhow, so, they say here, don't put too much trust in infinity-based computation. It isn't mathematically sound, and it will quickly lead to the next special number, which is NaN, or not a number. Hey, welcome. I don't know what that is, Danilo. All right, so not a number stands, or NaN stands for not a number, even though it is a value of the number type. So if you were to check if it is a number, what you can actually do, let's see if it'll let me. What did I just do? Okay. I don't know what I just did, but what I was trying to do is come down here. So console.log, type of NaN. This should still give you, oops, what did I mess up? I have to put this in like, that doesn't make sense. No, it's just going to give me the string. I don't know what I did wrong. Anyhow, it'll basically give you a number type. That's all it's saying. So it is a number, even though it's not a number. Okay, so yeah, so if you do like 0, 0, infinity minus infinity, or any number that doesn't actually like represent a result, then you'll get NaN. So you do have to check against that, or if you like try to do weird math with strings and stuff, because you can't like always know what the values are that you have in JavaScript, since it's not a strongly typed language. Yeah. All right, cool. All right, let's keep going. I should mention, by the way, like I'm all self-taught, so I'm sure I'm going to learn a ton in this book, just because like when you're self-taught, you kind of learn what you need to do the stuff you have to do. And so that's a lot of the reason why I wanted to do this. So hopefully at the beginning here, I'll know most of it, but I'm assuming there's going to be a ton I don't know or like explain wrong, because I don't have a CS background. So especially if you do, and for some reason you want to watch beginner JavaScript, then let me know if there's something that I'm ever messing up. But right, next basic type is a string. Strings are used to represent text. They're written by enclosing their content in quotes. So I'm assuming they're going to talk about this, but you've got 3 different types. This backtick allows you to interpolate stuff directly in there, which is really nice. You can use obviously the double quote or the single quote. There's nothing like special to them necessarily, just that you have to pay attention to which ones you're using. For instance, if you're using it to represent like a quoted text from a book or something, and somebody uses the quote symbols in that, it'll stop your string early. And I'm assuming they're going to show that here, but if not, I'll show you in a second. So you can put almost anything in between quotes and you to make a string in JavaScript. There are other ways to make strings. There's also other ways to make numbers as well. Maybe we can look at that in a second. All right, so you can imagine how putting quotes between quotes might be hard since they look like the end of the string. That's what we just talked about. New lines as well. That's the character you get when you press enter. They can also be included, but only when you use backticks. So if they don't show us that, then I'll show you here in a second. So to make it possible to include such characters as the following, like backslashes or other things like that, a backslash is used to include those. So this is called escaping a character. And this allows you to say, like, don't see this as the normal character you would see it as because it's special in JavaScript or whatever. Instead, just see it as its character alone. So I don't know if they're going to show this here, but yeah, like here, this \n says this is a new line, so wrap it. Or you could use backticks. So if I come in here, let's look at that. So I could come in here and say, actually, let's just do it directly like this. So I could say something here, and then I could end here like this. Like this would be just fine. And notice it actually says, oh, that's the same thing as this right here. And it actually doubles it because I did 2 spaces, and this backslash tells you what that would do. Now, if I come back over here and let's now do like, hi, she said, notice how like that breaks the string, and that's what they're saying. But what I could do is come over here and I could add a backslash before here. And then notice it just assumes that this is an actual quotation mark, but I don't have an ending one. So I don't want to do the same thing here, which kind of gets messy at some point. So you can actually switch between them, and that way you don't have to do this like end thing constantly. So if you know you're going to use those quotes, you might use something like a single quote on the outside here. Oops, like that. And then you don't have to escape this kind of stuff because it's inside of that section. So it's going to count it as like part of that actual string group as well. So sometimes you'll use these. If you use these backticks, then you can use whatever you want inside between those two, and it's just fine. So hopefully that makes sense. All right, we just looked at that. There are, of course, situations where you want a backslash to be just a backslash. So you have to, so if 2 backslashes follow each other, they'll collapse together. So basically you use a backslash to backslash a backslash. So if you want it to actually be that way, then that's how you do that. So a new line characters are written like this can be expressed like this. So this backslash escapes this one. Strings too have to be modeled as a series of bits. We can talk about that in a second maybe as well, but the way JavaScript does this is based on the Unicode standard. You don't usually have to think about this too much unless your language happens to use special characters or things like that, but I'm sure that they'll talk about that later. JavaScript's representation uses 16 bits per string element. It can be described up to 2 to the 16th different characters. Unicode defines more characters than that, about twice as many at this point. So some characters such as emoji take up 2 different character positions. So that's a little bit more complex in the way that we're dealing with strings, and I'm glad they're going to cover that later because that's not super common. You can combine strings. This is called concatenating them. So you're not like multiplying them or dividing them or anything like that, but you can basically smash strings together, and there are several ways to do that. So the first way here is like this, where you just use these plus symbols and you add all these things together. And then obviously it smashes them all together, and it's called concatenate. It kind of glues them together. There are other ways to do that as well. And typically, like if you're combining just straight up strings like this, it's usually through the use of variables, which we haven't looked at yet. All right, so string values have a number of associated methods that can be used to perform operations on them. We'll talk about this in a second here when we talk about like, different like methods that live on what these values, like numbers and stuff like that. Strings written with a single or double quotes behave very much the same way. The only difference lies in which type of quote you need to use. You need to escape inside of them. Backtick quotes. Strings called template literals can do a few more tricks. That's what I mentioned earlier. So you can actually interpolate values inside of here, embed values inside of here. So here we're saying half of 100 is, and the way that you interpret other values, whether that's just raw numbers or actually other variables, which we haven't looked at yet, is by using this syntax right here, where you have a $sign and then these curly brackets that kind of wrap stuff. So here we're doing math directly inside of here, and the end result of this will be half of 100 is 50, right? So anything inside this little template literal will be computed or grabbed from memory if it's representing some other value. Okay, unary operators. So we'll talk about that in a second. I do want to talk a little bit about string math since they didn't bring that up. I'm sure they will later. Since we're here, you can actually do weird stuff with math in JavaScript, believe it or not. So you could do like 10 minus, you could do 10 minus like 2 here, and it gives you 8. Now what's going on here? Because you've got a number, and then you've got, let's make that bigger. You've got a number, and then you've got a string, and you're actually doing real math on it. JavaScript does this thing called coercion, where it actually will try to move a value from a string to a number if it's possible. So you do have to be aware of that, because sometimes you can get yourself in sticky situations. So you always want to make sure you're working with numbers. Again, this is something I'm sure they'll talk about later. But with a lot of these things, you can create numbers or strings different ways. So for instance, I could go number like this and then produce a new number. So like 2 or whatever, and that gives me 2. But it's a lot easier just to use the value 2. There are some times though where that's useful. For instance, if you're taking in a value that's a string and you want to force that coercion to a number, you could say like, I know this is a 2 here, but I actually want to coerce this to be a number. So you can say number 2 like this, and that coerces it, tells JavaScript this is actually a number, even though it's a string. Now, obviously, there are other ways you want to handle this, especially once you start using things like TypeScript. You can define that and kind of get at least like development time, some safety there. There are other ways to do this as well. So I don't know that we need to go into all this, but you can do a plus on the front of this. That's another shorthand for that number. You can parse, if I can type, you can parse an int, an integer, you can parse a float. So there are other ways to kind of force this coercion between the two things. And you'll learn some of those as you go. But just to mention, like up front, make sure that if you're doing math, especially, that you're actually working with numbers. Otherwise, you can get in kind of some sticky situations. There are a bunch of other things with like multiplication and that kind of stuff with JavaScript that are kind of funky. So like even, I don't know if you do 0.2 times 0.1 or whatever, you get this massive number here. And that has to do with the capacity of JavaScript to run math. So there's some extra things you have to pay attention to. This is especially important when you start doing like math with currency. So you say like 100 cents minus 99 cents or whatever. Especially once you start doing multiplication and division, like there can just be some funky stuff. So that's just kind of a note to stick away for later. We don't have to really worry about that for now. All you need to know for now is that the easiest way to declare a number is just by typing the number. It can be a decimal, it can be a whole number. And then with strings, the easiest way is to just use quotation marks. If you have to have embedded quotation marks, either alternate the type or you can also escape characters as well. All right, so that's kind of where we're at so far. Looks like we're maybe halfway through this. All right, unary operators. Not all operators are symbols. Some are written as words. So one example is the type of operator, which I tried to use earlier. I don't know what I messed up on, which produces a string value, naming the type of the value you give it. So like this right here gives you type of 4.5 should be a number. Type of X should be a string. So you can use that to kind of figure out what you've got in JavaScript. We'll also use console log in the example, which we've already looked at a little bit, but we'll look at more. There's a bunch of other ways to write to the console, and these basically help you debug as a developer. Usually you don't, like those aren't customer facing. Other operators shown in this chapter, all operated on 2 values, but type of takes only 1 value. Operators can be used that use 2 values are called binary numbers, while those that take 1 are called unary operators. So the minus operator can be used both as a binary operator and as a unary operator. So anyhow, hopefully that's useful to you. I actually don't know that I knew that this was called that, but again, that's what happens when you're self-taught. You just miss little things. So I think this book will be good for me. All right, Boolean values. So we've had numbers, we've had strings, now Booleans as well. These tell you if things are true or false, essentially. So you can do basic comparisons like this. Is 3 greater than 2? So this one should be true. Is 3 less than 2? Should be false. So these are traditional signs for is greater than, is less than. And these produce for you binary results, yes or no, true or false. Now, you can compare these the same way. This is going to say true here, but it's obviously a little bit odd. Like, how can you say this is less than this? Strings are ordered is generally alphabetic, but it's obviously not quite right. There's other ways we'd want to handle this. I don't think they're going to probably tell you about that right now. Yeah. But just note that for the most part, we would be dealing with numbers when we're doing comparison, like greater than, less than. We can talk about other things you can compare as well. And then generally with numbers and things like that, you're going to want to use like these. With strings, you'd use these kind of operators. So let's talk through those. Looks like they're going to walk you through a few of these. So this is called, like, obviously it's an exclamation point, but it's the bang operator. And it basically says that something is not the case. And let's see what else they show you here before I just start chatting. So yeah, there are other comparisons is all they're going to get into right now, which is fine. You can also combine some of these. So like greater than or equal to, less than or equal to, equals right here. There's also a double equals, which we'll look at in a second. And then this is not equals to. There's one value in JavaScript that is not equal to itself, and that is nan, is not a number. So these things are not the same. It's false. Everything else should be compared to each other, which I don't know if I actually knew that or not. Let's see what they're going to show you down here. Okay, so they're not going to show you that. So let's look at a couple things then. And again, I'm sure they'll get to this later. So this is all just kind of bonus stuff. You can compare stuff in a couple of different ways. So for instance, I could say, does 1 equal like this with a double equal sign? So a single equal sign assigns a value to something, which we haven't looked at yet, so we don't have to worry about that. But if you're comparing things, you can use this. And I could say, is it equal to 1? Now, if I just use the double equals there, then it shows just these values, like basically when we're all said and done in JavaScript, could they be the same number? Could they be the same value? And in this case, it's a string and a number. So they're not exactly the same, but you can basically coerce the string to be a number. So it says, yeah, that's fine. If you use a triple equal, this is generally thought to be more safe. Then you're actually saying, I need to know if they're the same type and the exact same value. So in this case, they obviously are not. You'd have to have this as a number for that to be the case. So that is one thing to think through. Like I mentioned, there's also this like bang operator. Does this not equal? This is confusing here. But you can actually take this string here. This does not equal this. That's true. When you add a bang operator, this right here, the double equal kind of becomes a single equal, and this becomes the double equal. Maybe that's confusing. Let me say that again. So normally if you do a double equal, you're doing a kind of a loose comparison. If you want to do a strict comparison between the type and everything else, then you have to add triple equal. Once you go down and you add a bang operator, then if you check if these things are not equal, you would just simply use this one. That's kind of the loose value. And then if you want to check if it's not equal and check the types as well, then you use this one. So this is definitely not equal to the other one. Hopefully that's clear as mud. And again, we have numbers like this. So let's say 2 here. Is 2 less than or equal to 2? Yes. But obviously if we get rid of this, that doesn't work. We could check if it's equal. Again, you could triple check. That's fine, but it's going to be the same value because they're both the same type, right? Same value of number. Sorry if I'm mixing up value and the actual value in JavaScript. Okay, hopefully that semi made sense and I didn't make that more confusing. We've also got some logical operators, and there's actually several semi-new ones in JavaScript, which are really nice to work with. These are called, they can be applied to Boolean values. JavaScript supports 3 of them, and or not. These can be used to reason about Booleans. Yeah, it is, Terry, beginner level. We're just starting at the very basics, and then we'll go chapter by chapter. Sorry, I missed your comment. The double and operator represents logical and, which we'll look at in a second here. You also have or, which is this double pipe. This is not an exclamation point. There are actual pipes here. Let's see what else they're going to talk through. Yeah, okay. All right, cool. So it's a binary operator, this double and its results are true only if both values are given. So it's like a shorthand way of saying, like, if this is true, then do this. You're just saying, like, if this is true, then give me this. And if this is false, you'll never get this at all. So this can be a nice way to shorten up stuff. It's not usually quite as readable, but it's popular enough that it's perfectly legitimate to use. The OR operator says basically if either of these things are true, then go ahead and do what you were going to do. It's not written as an exclamation point, like I mentioned. It's an actual, pipe character. Oh no, they're talking about not. Yeah, if it's not the case, then that, which we already looked at. So not true produces false, not false gives true. So that's another operator. Sorry, I thought they were saying it's not an exclamation point, which is true. It's not. It's a pipe character. So you can mix these things with arithmetic and other things like that. So it gives you a lot more flexibility. There is an actual order as well. So this double pipe has the lowest precedence, then comes the double and then come the comparison operators. So sometimes you need to do like combinations of these things. Honestly, if you're doing this, no one else is going to want to read that. So your code's bad, but that's fine. They're basically showing like what order will these things happen in. So if you're chaining a bunch of these things together, you need to know the order of that. But usually that means like you're making code that's like really smart, but not readable to anybody else. And it's going to be a pain in the neck to come back to. The last logical operator we'll look at is not unary, but not binary, but ternary. So you actually have 3 different values. And this is super helpful when and I actually already showed you how to do this a second ago, but it's written as a question mark and then as a colon. And again, this is not quite as readable, but generally speaking, people use this a lot. So it's helpful to know. If this is true, then do this. If it's not true, then do that. Now, there are ways to write if statements in JavaScript. I'm sure we'll talk about that soon. But these kind of conditional things that are like real compressed statements are super nice because you don't have to write a whole loop where you say like, if this is true, then do this. And like this whole code block can be kind of just way too verbose sometimes for what you need. So let me give you like a really clear example of what this could look like. So if I had like a certain number of items, so I want to say items, but if I only have one item, I only want it to say item. So if I'm writing this out like on the screen for somebody, let's say they have 0 items in their cart or 3 items in their cart or 1 item in their cart. Well, I want to know, should this S be there or not? One of the things you can do is come inside here. See if it'll actually just let me do it like this. Can I console.log? Yeah, let's do this. So we'll console.log inside here. And so what I can do is say like, if true, then all I want you to do is give me, so like if it equals to 1, all right, whatever this happens to be, that's kind of the idea here. If actually, we'll just say if 1 equals 1, right? If it equals 1, whatever the thing is that we pass in, then we don't want to pass anything. We want to pass an empty string. Otherwise, I want to pass something like S, right? And then this would log that out for me. It doesn't know what item is. Oh, maybe there's already an item in my memory. I don't know what's going on here. But basically, it will either print this out as items if it's false or item if it's true. So that's one way in which it's like really nice to have this little compressed statement you can use within a string literal in that case. So this ternary operator becomes really important and helpful. Okay, cool. There are other values here as well. I mentioned there's some newer ones. So there's like a double question mark, which is a nullish coalescing operator. There's a bunch of other ones as well. I'm just assuming they're going to talk about those later, but these are kind of the basics. If this is true, do this. If either of these is true, then move ahead or whatever it happens to be. Okay, down this way, empty values. There are 2 special values. I wish there wasn't in JavaScript, written null and undefined. It'd be really nice if we didn't have null because that introduces a bunch of things, but that's okay. These are used to denote the absence of meaningful values. They are themselves values, but they carry no information. Awesome. Hey, Alex. It's useful for very short things like your examples right now. The ternary. True. Okay, many operators in the language that don't produce a meaningful value yield undefined simply because they have to yield something. You can actually set things to undefined as well. But yeah, the difference between undefined and null is an accident of JavaScript's design. Like I mentioned, it doesn't matter most of the time. Null is basically useless and creates more issues than helps, in my opinion. Okay, automatic type conversion. Hey, we already talked about this. Look at this, we're getting ahead. So in the introduction, which we did not read, I mentioned that JavaScript goes out of its way to accept almost any program you give it, even programs that do odd things. That's some of the power of JavaScript, is you can kind of do a lot of dumb stuff and it kind of figures it out for you. But it's less precise in that way and can lead to a lot of errors. So for instance, 8 times null equals 0, which is not something, right? The number 5 minus 1 equals 4. We already looked at that. You can add these, and I didn't talk about this, but when you add a number, it doesn't like add it like 6. It actually adds it, like smashes it together and makes it 51, which is a weird thing. 5 times 2 is not a number because it doesn't coerce this thing to an actual number. It just reads it as a string. And then false equals 0 is true because false is a falsy value, which we haven't talked about really yet. But so there's lots of weird things you can do in JavaScript accidentally if you're not careful. Usually it's within some kind of logic block or something like that. So when an operator is applied to the wrong type of value, like a number to a string or a Boolean to not a number or a string or whatever, JavaScript quietly tries to convert that and does the best thing it can. It's called type coercion, which we've talked about. The null in the first expression becomes 0. So it says, oh, there's nothing here. Since I don't have that value and we're doing a multiplication, let's make this thing a 0. And the 5 becomes 5 from string to number here. And the third expression, though, plus tries that concatenation, so it converts the number into a string. So again, it does some weird stuff here. And you just have to know what type you're working with, basically. If you do that, then you don't have to worry about this. But sometimes it can be helpful as well. All right, when comparing types of values that use the same type, this is what we also talked about, I think. Maybe not. The double equal operator is the outcome. The outcome of that is easy to predict. You should get true when both values are the same, except in the case of Dan. That's the only one that doesn't work that way. When types differ, JavaScript uses a complicated and confusing set of rules to determine what to do. So in most cases, it tries to convert one of the values to the other. That's that type coercion, which is a little weird. When null or undefined occurs on either side of the operator, it produces true only if both sides of the value are null or undefined. So again, this type coercion is helpful because JavaScript is trying to kind of do a lot of the work for you. It's not helpful because it's trying to do a lot of the work for you. Okay, so like I mentioned, that behavior is often useful when you want to test whether a value has a real value instead of null or undefined. You can compare it to null with the double equal operator or the not equal operator. All right, what if you want to test if something refers to a precise value false? Expressions like 0 equals false and empty string equals false are also true because of automatic type coercion. We'll talk about that a little bit more. When you do not want any type conversions to happen, there are 2 additional operators: this double equals and the triple equals and the bang double equals. So these check both the types and the actual values as well. All right, so usually we use the 3-character comparison operators, and that basically helps you check against the type and the value as well. So it kind of gives you control of the coercion rather than letting JavaScript do that. Let's talk a little bit about this whole thing, which is a little bit weird. So there are lots of different things within JavaScript that are true or false, to kind of depending on what value you enter. So for instance, like 1, let's see if this will. Yeah, okay, that's fine. If we do console.log, so we can check if something is like false. Let's just do it like this. All right, so if I come in here, like if I do, why is it not giving me our readout here anymore? What if I just do 0 equals false? Will it give it to me? Because it was giving me readout down below. Yeah, there we go. Okay, it's because I was trying to help. All right, so 0 equals false here. Now we're going to use just the loose operator, because if we do this, then it actually checks, which is what they were just saying a second ago. But there are lots of values in JavaScript that are either true or false. And what I mean by that is, like, sometimes we're asking, does it exist? We're not asking what the value is or what it like resolves to. So there are lots of things in here. So like null and undefined. I already mentioned 0. Affinity is also false. So there's lots of values in here. If I do, this is not showing me correct. correctly. Anyhow, but basically there are things that are true or false. So like, I don't know, truthy values basically and falsy values. So whatever I'm doing in the console is messing up. I don't use the console like in the browser a ton, so I forget how that works. So clearly I'm messing that up. So I'm probably just adding confusion to it. But basically, in addition to like the Boolean values, obviously there are things that resolve to true or false. And that's what they're saying here is like this empty string resolves to false. So we'll learn what those are in a little bit. It's helpful when you're doing like logical comparisons. And I'm guessing they'll do that by the end of this chapter, but maybe not. All right, the logical operators double ampersand and double pipe. They handle different types in peculiar ways. They'll convert the value on their left side to Boolean types in order to decide what to do. But depending on the operator and the result of that conversion, they will either return the original left-hand value or the right-hand value. So they just get really kind of funky. So again, know what types you're working with is the kind of the main takeaway. So the double pipe operator, for example, returns the value to its left when the value can be converted to true and will return the value on its right otherwise. So here, this one isn't true, so it's going to return this one over here. Whereas this one is true, so it returns this one first. This has the effect of when the values are Boolean and does something analogous for values of other types. So just know kind of what you're working with. And what we're basically saying is if either of these are true, this is not going to resolve to true. It's going to resolve to false, so it gives me this one over here. This one would resolve to true. This is what we were talking about earlier with like resolving things, because it's just asking, does this exist? We're not asking like, does it equal the Boolean true? Now we can use this functionally in a way to kind of write fallback values. So if you have a value that might be empty, you can put the double pipe after it with a replacement value and say basically like, hey, I think this is going to be there, but if it's not, here's your backup and use this instead. So the rules for converting strings and numbers to Boolean values state that 0, not a number, and the empty string all count as false. They resolve to false, while all other values count as true. That means 0, this -1 produces -1 because 0 is going to resolve to false. The string, this, and whatever else yields to this because the empty string, again, is going to count as false. It resolves to false. Okay, the double question operator. Oh, they are going to bring this in. Cool. Resembles the pipe, but it returns the value on the right only if the one on the left is null or undefined. So it's a little bit more precise, not if it is some other value that can be converted to false. So usually you try to use this double pipe. This, like I mentioned, it's called knowledge coalescing. I don't know if they show that here or not. But yeah, so usually they use that instead. Now, like I find myself using that way more instead because it's a little bit more precise. So again, the difference between the two is over here. If the first value can resolve to false, then it gives you the second value. Whereas this one, it returns the right only if the one on the left is null or undefined. So if it doesn't exist at all. So you could pass in an empty string over here. So I could change this to an empty string like this. And you'll notice here, this, I was like, why isn't that working? So there, we're going to get the 100. Whereas if I come over here, what does it give me down this way? Oh yeah, it's giving me 0. So don't pay attention to this. It should give me this 100. Yeah, this 100 right here. What am I getting here? Here, let's run it like this. It gives me the empty string. That's why it's not showing it. It's not showing the second line. So here it will actually print back the empty string. Here it's printing back 100 because this only will return the second value if this is actually null or undefined, not if it's a value that can be converted to that. So usually this is preferable. This is usually what I use when I'm doing this kind of comparison. The double ampersand operator works similarly, but the other way around. When the value to the left is something that converts to false, it returns that value. Otherwise, it returns the value on the right. Another important property of these two operators is that the part of the right is evaluated only when necessary. So if this one is true, then it never even looks at this. And that's helpful if, especially when you're using the like double ampersand, wherever that one is. So if we were to change this to a double ampersand, and here what we're saying is if this is true, then go ahead and give me 100. So place your bets now. What do you think is going to happen? Nothing shows, right? Because this is going to evaluate to false. So this will never even be looked at. Whereas if I come down here, let's change this to something like 1, or it's a string of 1 in this case. I'm saying if this is true, then give me this. What do you think is going to happen? It should give me 100, right? So it's going to actually look at this second value and give that to me. Okay. Another important property of these two operators is the part that to the right is only value when necessary. That's what we just looked at. So in the case of true, this X, no matter what X is, it doesn't really matter. It will just give you true back as the value because that evaluates to true. All right, the conditional operator works the same way. That's the nullish coalescing operator of the second and third values this is the ternary operator, sorry. The three things, right? If this is true, then give me this, otherwise give me this. All right, so we looked at 4 types of JavaScript values in this chapter: numbers, strings, booleans, undefined values. Such values are created by typing their name, like true or null, or value 13, or like a string. And again, there are other ways to create those things as well, but that's typically the way you do these kind of base values in JavaScript. You can combine and transform them. We saw this with like operators in string concatenation and comparison and logic. And then you can combine them, and sometimes you have to escape characters and that kind of stuff as well. All right, so the next chapter, we'll start typing these expressions together into basic programs. I want to like really quickly give a crazy basic understanding of my understanding of like how we need to think about like memory stuff, which they'll talk about as we get into values. But when you have a string like hi mom or whatever in JavaScript, this string has to store it somewhere in memory. And JavaScript does a lot of this for you. You don't have to actually assign this to like a space in your memory, which you do in a lot of other lower level languages. And it also kind of garbage collects it when you no longer need this string as well. So it's going to reference this like little bit of memory here. And let's just give this thing a name. We'll call it like 0A or something, okay? So whenever I reference this within my program, so let's say I'm down this way, and I'm saying like, let's console.log, and maybe let's just name this mom so I can include this here. All right. So I come in here, we've got these backticks, and I say like, hi, and then I want to grab mom. Sorry, mom. All right, so I say, let's reference this. And let's say I've given this is the value I've stored here, obviously. But let's say I've named this something, even though we haven't really. Thanks, Siri. Okay. So let's say I come back over here. I'm not sure what that was all about. And we're going to give this thing a name, which we haven't looked at yet. But I could say like const, I don't know, say like name. If I can type name equals, and then let's say I've named this thing mom. Now what I've done in this case is I've said, hey, I'm going to name a constant. We're going to call it name, and I'm going to assign it the value of mom. So this whole thing is going to be sent up to this little section in memory. And whether this is a string or a number or a Boolean or whatever, it's going to be stored in this section. So over here, I would just reference it by the name we gave it. In this case, that happens to be name. Now, when I run this, when this is run by JavaScript, the console log function is going to run, this method of log on console is going to run, and it's going to say, let me see where this is stored in memory. And it's going to grab it right here, and it's going to say, give me the value you have. And we've kind of stored this thing, call it 0A for now, but basically I've stored the name constant here in this little section of memory. So it'll say, hey, give me whatever name you have. It will go and look at its memory here and grab this item and return it to me. And then it's going to replace this whole thing with mom, right? So this will be right inside here, and it will actually, when it's done running that function, that will be the result. Where did it get that value? Well, again, it got it from its memory up here. Now, everything we've looked at so far, true, like Booleans, numbers, strings, these are stored like this. And if you change this at all, it will change it in this exact memory spot. We will talk about all this later, I'm confident. But there are other types of values in JavaScript, like objects and arrays, that don't store the actual value here. They actually store like a pointer to the value. So it gets a little bit more complex. So these ones that we've looked at right now, these primitives we've looked at, basically they always stay the same in their little spot of memory. But this is what it's doing in JavaScript. Again, that's super basic and not crazy helpful right now, but it will be as you keep going, that there are different types of ways we store values. So these ones, these kind of basic ones of numbers and strings and Booleans, they are stored as they are. And if you change them, they're always changed. Objects and arrays are a little bit different, and we'll talk about that as we go further on. Well, let me know if you like this kind of thing. There were a couple things I picked up on that I just didn't know what they were called, or didn't know that was like a thing. I think this whole refreshment of like why the nullish coalescing operator, I can talk, it's fine, was helpful because I always use that And I remember that's why I did, but it's been a bit since I've even used the double or. So, okay, I think that's it for today. Let me remind you about the campaign for St. Jude, and maybe some people even gave. I think maybe somebody gave during the stream. But again, I don't have enough people to give these prizes away to. You have to give just $5 and you'll be entered to win one of these raffle tickets. And you can win a bunch of really cool stuff from these companies, from Vercel, Cloud Cannon, Console Ninjas. Honestly, like, I have to have this in my terminal or my code editor. Dracula, which is a great theme. Git Tower, my Astra course, Mux credits for videos. That's super helpful. It's always what I use for video, and I'm actually going to do a video on it this next week. Neon, which is a database solution, Quokka and Wallaby.js, which run in your code editor, but do a lot of cool stuff with JavaScript, which we'll probably use, honestly, as we go through this book, because it means I don't have to constantly console log. I can just run it directly there. Wallaby.js runs your tests live, and it can be really helpful when you're developing. Vercel credits as well for hosting and anything else you might need. And then Warp as well, which I use as my terminal, my daily driver, and have for a long time. So I've got a bunch of these things to give away. All I need is people to help us raise money for childhood cancer. All right, cool. Well, thanks so much for all your help. Laravel Company, hello. I hope you guys enjoyed that. Let me know if you want to do more of this kind of stuff. I will probably no matter what, but hopefully you'll join me as well. All right. Cheers. I'll catch you in the next one. Happy coding.